Welcome to Integrated Math 3. On this episode, Stevenson will demonstrate Finally, let's take what we've done with quadratics and cubics and take what we've been learning about polynomials and let's start sketching polynomials. So here are 3 examples I have for you of polynomial functions in factored form. Let's work through this. First thing I want to do is I want to identify what my roots are. In y1 here, I can see my roots are going to be 2, 1, and 4. These are all distinct. But notice, what's my degree going to be here? Well, this is going to be x squared because there's 2 of them. This is going to be an x and this is going to be an x. So an easy way to do this is to expand it out. So let's rewrite y1. So what is my degree? We'll count how many x's are there. 1, 2, 3, 4. So my degree is 4. And my a value is positive. So I already know my end behavior is going to be up. Now let's actually work through the multiplicities. I have root 2 has a multiplicity of 2. Roots 1 and 4 each have a multiplicity of 1. They only exist one time. So remember, if the multiplicity is even of your function, if it's a multiplicity of even at your root, the graph will just touch the x-axis. If the multiplicity is odd, then it will cross. So let's put some estimate points here on where this will be. So let's see what's happening here. My multiplicity, where is it going to just touch the x-axis at? It's just going to touch the x-axis at 2, but it's going to cross at 4 and it's going to cross at 1. Now remember, the reason I know that is because 4 and 1, those roots have odd multiplicities. So I'm going to put a slash through 4 and through 1. And I immediately can see this arrow is too far to the left, so I'm just going to move it over. That way my sketch is a little bit easier. So I'm going to connect these sides. But in order for it to touch 2, it has to just bounce off 2. So I have 2 options. I could have it touch the x-axis from below, or I could have it come from above. Well, to figure out what it is, ask yourself, what happens in both cases? Remember, I can't cross the x-axis again because it would create another root or x-intercept that I don't have. So in this particular case, it has to touch 2 from below. So it's going to be kind of like a W. So let's look at Desmos here and see how we did. There you go. So there's our 2, whoops. It's just barely under there, but it is. It's because my y-axis is so big. It's gonna cross, touch, and then cross, and then it'll be on the other side. So again, the first step is to figure out what are your x-intercepts. But actually, in order to do that, you may want to expand it out so you can see what all the terms are. Now let's determine the roots, which are the x-intercepts. Notice I have 3 of them. So I have 3 distinct roots. What is the degree of this polynomial? Well, count the x's. 1, 2, 3, 4, 5. And is the a value positive or negative? Well, the leading value is positive, so it's going to be like that. So if the degree is odd and our a value is positive, then we know our end behavior is going to be opposite and in some kind of direction like this. Again, if we have to move them like in the previous example, we will. So let's put some points down for 3. So let's say this is 3, we'll say that's 5, and we'll say that's -1. Now let's figure out the multiplicities of each one because the multiplicities is going to tell us if it'll cross or not. So as you can see, your multiplicities, by the way, should add up to your degree. It's a way to check your work. So look at the previous problem. The degree was 4, right? But add up the multiplicities. 2 plus 1 plus 1 is 4. Check it here. 2 plus 1 plus 2 is 5. So root 3 has multiplicity of 2 because it's 2 times. So that means the graph is going to touch at 3. Root -1 has a multiplicity of 1 because it only happens 1 time. So the graph will cross at -1. And root 5 has a multiplicity of 2 because it happens 2 times, which means the graph will touch at 2. So let's start sketching. So the first x-intercept or root I have to deal with is -1. And according to my notes here, it's going to cross because the multiplicity is 1. So I'm going to sketch it like this. It's just going to cross. Now at 3, the multiplicity is 2, so the graph must touch, not cross. So there it is. And at 5, the multiplicity is also 2, so it has to touch again but not cross. So I'm going to go ahead and move my arrow. So let's see how we did. So again, how high or how low you make that relative extrema does not matter. So you can see it crosses, and then it touches, and then it touches. Let's do one more. So first step is expand it out if you need to. Next, we're going to figure out, let's figure out the degree and the a value. So if the degree is 4, that's even, but the a value is negative. So that means the end behavior is the same because the degree is even, but it's going to be down in both cases because the a value is negative. So let's figure out the multiplicities. Well, actually before that, let's do the roots. So I have 3 distinct roots, but notice one of them repeats. So let's list out the multiplicities of each root. So let's check our multiplicities, make sure they add up to our degree. 2 plus 1 plus 1 is 4. So let's plot some points here at -1, -2, and 4. I'm going to start with root -2. I'm going to go left to right. So at -2, the multiplicity is 1, which means the graph must cross there. At -1, it has a multiplicity of 2. It's even in multiplicity, so it just has to touch. And then at 4, the multiplicity is odd again. It's 1, so it has to cross. So let's see how we did. So it's a little hard to see here, but we can see that it crosses there. There's a little bit of space there. It touches at 1, and then it crosses again at 4, just like we said.